Then let me start and first introduce myself. My name is Lena Oden. In my first life, I'm a professor for computer engineering in Hagen, but while I'm here, I'm also working at the Jülich Supercomputing Center, where I'm co-leading the work package 6, which is about basic infrastructure, and I'm basically responsible for everything that is related to cloud and HPC computing. And why I'm here and what I will talk about today is I will first start on a basic level what actually is cloud computing, what is HPC computing, to get a feeling and to get an idea what kind of services we're actually offering. Then I will give an overview of the computing and resources and services which are offered in eBrains with Phoenix. Then I will tell you how to get actually access to the systems if you want to use it in your research. And then I will show some services and use cases actually use our compute resources in the past. But first start with this kind of beginning, because I was not knowing what kind of audience is, and to me it's totally clear what is HPC, what is cloud computing, what are the difference, what do I need for what, but I'm used to it now. Not everybody knows what is HPC. So let's start. What is HPC? Basically, an HPC computer is a very large computer, as you can see here, with a lot of racks and cabinets, and you have a massive compute power, and you have a lot of processors, usually each with multiple cores. You have I/Os, so usually you have a dedicated storage devices which are just there to provide data. You have very fast, high interconnect, so this is basically a big difference to other systems that you have InfiniBand or OFI, so very specialized interconnects which are required for the kind of workloads. And you very often in these days have also GPUs included in your systems. So here you have a picture of a single node, and here you have a picture of a complete supercomputer. And if you come to the general idea how to work on this, basically you parallelize your application, so you split up your big computation into a lot of small problems, and a lot of the simulators used inside eBrains are doing this for you. And in different steps, and in your application these steps are communicating over this high-speed interconnect. And basically, for the efficiency of an application on an HPC cluster, the communication patterns and also the communication is very important. So you don't have a lot of single jobs you're running, but you have one big job using a lot of compute resources in parallel. The problem with HPC is actually the users of these resources. Basically, first of all, it's not that you just log into a supercomputer, use it like a normal computer. Basically, they are based on batch stop. This means you describe your job, it's submitted to a queuing system, and then you wait until your job is completed, and then you can get the results. And basically, have a scheduler which decide when to run what. We are now also working on an interactive mode, which is also part of Work Package 6. We have more interactive access. And to be honest, HPC is in some areas a very, very slow-moving field. The usual access mode to HPC systems for a very long time was SSH, a console, a black-white interface, very hard to use. And basically one thing we are trying to change in eBrains is this access mode. And hopefully I will come to this. But usually you have this batch mode, write a batch script, submit it, wait, and nothing fancy, colorful. Cloud computing on the other side. Basically, there's a lot of definitions, and I'm not giving a lecture about cloud computing today. This would be a different topic. And I stole this nice picture from Wikipedia. So basically, cloud computing, the idea is to have compute services, storage services somewhere, and as a user, you can access them from different areas and just use these resources. And a lot of things in cloud computing are based on virtualization. So usually you have a virtual machine you use where your application is running. In our days, you also have very often containers where your application is running, something which is not really used at HPC. And so you get compute resources and also very often software as a service. And basically, if you have ever used eBrains and some of the services in eBrains, like the collaboratory or the most of the Jupyter Lab interfaces or the knowledge graph, basically you're already using the cloud resources because this has to run somewhere. And currently this is running all the services on the cloud resources because they provide this basic access to compute resources, not the big and massive ones, so basically on cloud resources. So they can be the same, but usually because of the virtualization, they're not made for HPC workloads. Everything else you can run on a cloud resource. And now we come up, so this is the theory behind. Now we come up to what we're actually offering inside eBrains and in Phoenix. So now we talk about Phoenix more or less. And we have here, I think this picture was shown the day before, we have our 5 computing centers, Jülich, CA in France, Barcelona Supercomputing Center, CA in Switzerland, and Sinica in Italy. And they all provide different kind of resources and services. HPC resources on some side, on the other side cloud resources, and especially cloud and storage services, also on the cloud and in the HPC side. What is IC? So this is the infrastructure project. It's a child project of the Human Brain Project to provide basically this basic infrastructure. And we're in work package 6. We are basically making the infrastructure in between. I think my next picture helps a little bit to explain the differences between the both. So we have here the basically the services we have. So we have our this is very small, I don't think it's readable, but we have our compute resources, we have storage resources, everything which is probably required for computational workloads and cloud services. On top of this, we have this federated infrastructure services, which are provided by the IC project, which is, like I said, a child project, but we have a lot of personal union between people working in HBP and Phoenix, so there's a strong collaboration. And on top of this, we have eBrains, which basically should use these services. And there we have the collaboratory, for example, also the Neurobotics platforms, and they should all use this infrastructure to get access. Basically, Phoenix and the idea, so Phoenix is the longer term, so IC is a project, and Phoenix is the infrastructure. I use them sometimes in the same manner. It's not basically not only developed for eBrains, but should also be available for other users, but it was designed in the first place for the HBP, and therefore most of the things done in IC are done for eBrains. Yeah, but you can also, a specialized user, if somebody wants and still wants an old manner to use HPC systems, he can still go directly to this by using eBrains. And what makes eBrains special, in Phoenix special, also in contrast to, let's say, other projects and pure cloud providers, is this close approximation between cloud and HPC resources. So we have both. We have cloud resources and we have HPC resources. And actually, I will come to this later, we will have tools and services working between these two services. And this is kind of unique. So again, kind of what is provided by the IC project makes this clear what actually we have. What is this top layer here, this one here. So we have Phoenix User and Resource Management Service, which is across all sites, which is also kind of unique because usually you have your account and your resources on one individual center and not everywhere. We have federated authorization infrastructure, which is nice because you can use with your eBrains account, and if you have compute time and resources, you can use all these resources with your eBrains account. You still have to register and accept, if you run on a supercomputer, the regulations from this computing center, because they all have different regulations, but once you have done this, the authorization services allows you to use all these systems with a single account, which is usually not the case. Then we have this data services, which moves data between cloud and POSIX storages, which are used in HPC systems. We have Lustre and OpenStack. So Lustre is usually the file system used in HPC systems, but now it works together with OpenStack. And Swift and Station, but this goes very to technical details. And we also have a slide about this interactive computing on HPC systems. And I will skip this, but basically the idea is that the design of Phoenix is driven by scientific use cases with the following requirements. We want to share data from diverse and distributed data sources, and we want to enable services and portals like the collaboratory metadata service, so the knowledge graph is running on Phoenix resources, and compute services like brain simulators, which can run on supercomputers or with one integrated infrastructure. And one goal, which is not 100% working, but for our first use cases, we want workflows running on different sites, on different compute resources in one workflow, which includes HPC and cloud resources. Yes. So just to explain how it looks, we have this architecture of Phoenix on a local site. We have our HPC network and the active data repositories, which is a parallel file system with a POSIX storage where you can access your data. And then we have our scalable computing and our interactive computing, which can use this HPC resources. And then we have the archival, I always pronounce it wrong, this object storage for long-term on large data storage, where you can actually store data also to share it. And we have the site network connecting these two sites. And here we have also like virtual machines running on this cloud site. But it's all connected via this local network.
I have a question then. So it is for different communities, so it is also very focused on the neuroscience community. So someone, a special user, can go directly and use all the infrastructure, or they can use some layers that are above.
So the idea of eBrains is to have this layer above it. So you don't have to care, and the idea is of eBrains to develop an infrastructure which is on top of this and can use this. But if you have a very advanced user and also other communities, they can also use this directly, as I said in the first picture. Just as for completeness, so what we are actually doing, so to just bring this together, what we're doing in HBP and what is Phoenix. So basically we adapt all these resources offered by Phoenix to eBrains, like this user and resource management and the authentication and authorization services. And we integrate and working on the integration of these services together, sometimes with the technical coordination inside the eBrains infrastructure. And what we also do, what you should not underestimate, is the operation of all the services, because somebody must be responsible that software is running, that software is reinstalled and help desk, of course. We have monitoring service. We have this data transfer and data location service. I will come. This is something very detailed, a technical feature for data-intensive applications. We have this infrastructure for interactive and usable workloads, and we have some security assessments. So I will not talk about this, but basically we also try to get a common security infrastructure across all European centers, which was shown to be very important, especially with upcoming political events. So talking now about what kind of services we actually offer, which is probably not directly used by eBrains users, but more or less by the people developing tools on top of eBrains. And these are the data services. So on one side we have the central data location service. So if people store big data sets, and usually this big data sets should be stored in the object storage. This is the cloud storage we're providing. And you have to find it. And the idea of the data location service, it's not completely developed yet, but the basic idea is that you can use a knowledge graph, and then the data can be stored somewhere, and you can locate your data where it's stored, and then you can get tools and other workflows to upload it. Then we have the central data transfer service, which is we have two different sites, and both have the object storage. And because of locality and usability, it's sometimes required to transfer the data between these two object storages. And for this, we have developed the data transfer service, which is based on the file transfer service from CERN. And here the biggest challenge again is you have here an account, usually you have here an account, and you have to somehow bring this together and then transfer the data and get all the authentication and authorization services together, and this is happening by the central data transfer service. You can also transfer data between two parallel file systems. So if you're running on two different HPC sites and want to transfer your data, this is basically enabled by Unicore, and this you can use to get cross-site HPC workflows to transfer the data by using Unicore. And last but not least, we have the data movers servers. This was not directly developed in HBP, this was developed in IC. But this one is responsible to transfer data between object storage and the parallel file system. So if you have stored your data set or it's located in the object storage and you want to use it in a workflow running on an HPC system, you first have to use the data mover to transfer the data there. And this is very technical, but in an ideal world, this should be integrated in workflows and then you can just use it. And I was also talking about interactive computing. So basically there are two challenges if you come to interactive computing. The first one is that usually if you want to run interactive computing on an HPC system, you have this scheduler, which is basically Slurm, which is based on this batch system. And then you have to get some kind, but if you want to do interactive computing, you basically don't want to wait until you get your resources. You just want to interact with the system and get direct access. And the first goal of this was to find ways how this interactive computing on scalable compute resources can be realized on a machine, which at the same time, because eBrains is not the only user of these systems, to enable this interactive usage. And basically, I will not go into detail because you should know about how Slurm works, but we have developed 4 different approaches. And now how to do this. And now depending on the center, because in Switzerland they have different rules and in Jülich they have different rules, we try out different of these approaches to get interactive access to supercomputing centers. But it's based on the politics, which is the biggest problem. But now we provide these resources in an interactive way. So if you have access to interactive compute resources, you basically can use them. The other way, which was discussed very much, is how to do this, because as I said before, you very often have only access via SSH, which are people not used to. And one way which is now discovered is basically having Jupyter Lab as direct access method to the supercomputing resources. And this is basically a screenshot from my laptop, because on Yusuf, the machine on Jülich, you basically can access the machine using Jupyter Lab already. But this should be integrated into eBrains at a different stage, but basically the infrastructure is there. Also very important what we offer is the monitoring service, because computing systems fail, they have problems, which is not nice, and we don't want to talk about it. And basically, to get all the information, which system is currently running, which is not running, where are problems, we have this central infrastructure monitoring service where you can look, and if you have an eBrains account, you can access it, and you can basically see in a matrix which services are available, what's the status, and so on. And you can get also email notifications if a system is down, for example, and if it's running again. And the difference is this all exists on the individual sites, but now you have a common overview over all systems included in eBrains, which is very helpful and very small. Also, in the monitoring systems, the neuromorphic systems are also included. So you get an over-eyes interview, and so this monitoring service helps a lot. And I was talking about FURMS before. So FURMS is for the federated resource distribution, and basically it helps you to, if you have access to multiple machines, usually you have an individual access on every supercomputer, on every machine, on every site, and you have to do it individual on each node, but FURMS can help you if you get compute resources on different systems. It helps you to get this common access everywhere, and then you can use this to distribute resources to people working on your project, people working using your software with a common interface. So FURMS is ready. We are now on the status to integrate it on the local sites. It's not running yet, but it's just a question of months. You can physically use FURMS to manage your compute resources with your collaborators. I guess now the interesting question, which will come up, how you can get access to Phoenix resources. Because in some services, as I said, you're already using it. If you're using the collaboratory, if you're using the knowledge graph and so on, this is all already using Phoenix services and it's already using compute sources, but sometimes you want your own service, or for example, you want to run your own big scale simulation on a supercomputer. And there, first you have to look what kind of resources are available. As I said, we have scalable interactive computing services, we have virtual machine services, and actual and active data repositories. So these services you can require for, and on the Phoenix website you usually get all the information you need. The infrastructure, as I said, is open for different kind of user and communities, and basically you have to apply for it. And it's free to use if you apply for it, and if your proposal was accepted, and it's based on a peer review process. So currently, in the current state, in the inset of the HBP, we have two communities and two perspectives how you can get access. One is a continuous call for all HBP members and HBP users and neuroscientists, including the partnering projects. They can always apply for compute resources all the time. Just fill in. I have the next slide how to do this. There's always an open call, so if you have a project which requires compute resources, you can always apply. Users from the outside, not neuroscientists or just people who don't want to use e-brains, they have quarterly praise calls where you can also apply for resources. And on the Phoenix website you can see the tasks. And who can apply? All European researchers, so you need a PhD minimum. As I said, it's free of charge. And so what I like to say is, I don't know, it's on the slide. So the difference between other calls is that in IC, basically you can apply for compute resources from different sites at the same time. If you use usual praise calls or if you use usual calls, you can just, most of the time, just apply for resources from one site. But IC allows you to apply for resources from different sites at the same time. So I did my last call in my other work package I'm working, and we applied from 3 different sites for the HPC resources because we needed it for experiments and to test everything. And this was very great that I don't have to do 3 different applications. I just had to do one, which is very helpful for scientists like me. And so you have this YARD system. It's actually linked on the Phoenix website. It's an online procedure. You have to fill out a form. You have to go describe your research project. It's not a lot. It's 1 to 3 sites and how resources will be used to get goals. And the point is, if you need some help. So sometimes you don't know how many resources to use. Just ask at the centers, their support, they help you how to do the math, how many resources do I need? Because I know that it's kind of hard sometimes because you have to do this core hour thing, and how many core hours do I need is often not very clear to people. So you can go there and and fill this out, and then you have the allocation committee, and then you get the results, and it usually takes 1 to 2 months. It kind of depends how many compute resources you require. So small projects go usually very fast, and if you go about a specific amount, you need a scientific review. On the website of Phoenix, we now have a compute example how less you can apply to get a faster procedure, but then you get access to it. And you can always ask for questions, and they can also get tips with your proposal. And what I learned, if your proposal is not perfect, they usually come back to you and help you to refurbish it a little bit, and then you get access. So it's not as hard as other points to ask for access. And just to summarize this is a mirror picture who can apply. Each European researcher, and it's free of charge. Ask any question to the IC coordination team. They will be happy to help you, and you can find more information about how to get compute resources on the Phoenix website. I'd like to conclude with some use cases. Actually, I said a lot of services are already running on eBrains, but I think it's also interesting what kind of other use cases we have. Basically, also, I have to skip the next slide. This was wrong, what was he? So the other services, we'll skip this one here. For what I have this already said, I guess, most of this. So I think the most interesting part is the use cases. So basically, this is kind of from our review. So inside the HBP, we have the 7 use cases, which also become some special support from our work package to run. And they are, if you can see, they are kind of split over the different service category. We have the cellular level simulation. We have this Neurorobotics platform, which gets some resources. We have the medical informatics platform, which gets some special requests, the human interval EEG platform, the virtual brain, elastic, and the knowledge graph. These are the basic use cases which are using eBrains resources and get some special support. And as one special use case, I like to talk about the Neurorobotics platform. For one reason, I'm not an expert on this, but it's one of the cool use cases which basically uses cloud resources and HPC resources, and actually interactive HPC resources at the same time. And basically the idea is so if you want to get more details about this use case, you can look at the Phoenix website about the webinar, and they give more details about the technical implementation. But it's for us just to get an idea how this works. And basically the idea here is you have a brain simulation running, Nest, and this is running on a supercomputing on the one side, and you have a robot simulation running on the cloud resources, and they exchange data with each other. So you simulate the human brain to move the robot. And the architecture diagram, so this is a picture from the Phoenix webinar, is you have here the Neurorobotics platform, and here you have your HPC system, which is Pitstein in Switzerland, and they have this, they use Unico and an SSH tunnel to connect the both, and basically they change data with each other. So here the brain simulation is running, and if one step was running, they send the data back to the Neurorobotics platforms, and then the Neurorobotics platform gives back information to the HPC systems and so on. And for this, of course, you need interactive access, because you cannot wait until your job is running and then wait more than 20 minutes and then you get the next step. So here they were the first more or less using resources, and I can just say go to the website and look at the support. And I will finish with a small video, because then I don't have to talk anymore, which is just summarizing most of my talk today. If it's running. This is something for all over the HBP, but with a focus on the last minutes on what is he doing? now comes the part where I wanted to show this video because this again shows the use cases all together, but I couldn't pop it. Okay.
Thank you very much.